Hello, my name is Keshwani. That's Keshwani, Keshwani. I have been solving GMAT problem, GMAT data sufficiency problems, that is, out of this book here, GMAT Review, the official guide, the 12th edition. If you do not own this book already, purchase one immediately. You should be able to find it at mba.com, the same website where you would go to register to take the exam, mba.com. The problem that I'm about to solve is the one that you're going to find on page number 274, data sufficiency problem, hence the DS, number 24. Number 24, let's take a look at it. See what they have to say. It says, if n is an integer, so they're telling us that n is an integer. N is an integer, which we all know simply means that it's a whole number. It's just a very fancy way of saying it's a whole number. It cannot be 2.5 or 2 and 3/8. It has to be a whole number. Either 2 or 3 or -1 or -5 has to be a whole number. The question simply is, if n is an integer, what they're asking you is n even? That's all they're asking. Is n even? Well, before we actually solve this problem, which there is not much in it, it's pretty straightforward and simple. But before we actually solve it, let's make a list of things, the concept that they're testing here. Okay, it's very simple, very straightforward. You don't have to memorize anything in it. You just use your common sense and use the numbers and figure out as we go along. That's what I do. I don't memorize it. So let's start here. The concept they're testing here is even times even. Well, the even times even, 2 times 4 is 8, so even times even is even. Let's keep on going. Odd times odd. Well, let's see. Odd times odd. 3 times 5 is 15, which is odd, so odd times odd must be odd. You see, like I said, I don't memorize it, I just do a problem. Odd times even, 3 times 4, 3 times 4 is 12, which is even. And of course, we're not going to have a 4 times 3 because odd times even is same as even times odd. So those are the 3 things you have to know. And then the second thing that they're testing in this problem is this one here, where we deal with the additions as opposed to products. So let's do the addition. Even plus even, 2 plus 4, 2 plus 4 is 6, so even plus even is even. Odd plus odd, odd plus odd, well 3 plus 5 is 8, which is even, so odd plus odd must be even. And finally, odd plus even, well odd plus even is 7, which is odd. And we're not going to have a fourth case because odd plus even is going to be the same as even plus odd. So these 3 you have to know, and those 3 you have to know, the 3 products and 3 additions. And like I said a little while ago, when I say you have to know, it does not mean that you have to go around memorizing it. There is no need to memorize it. Just do a simple problem as you go along. 3 plus 5 is 8, so 3 plus 5, that's odd plus odd. Odd plus odd, it must be even, right here. And so on and so forth. Let's do a problem now. Let's see what the first statement says. In the first statement, they tell you that n squared plus 1, n squared minus 1 rather, is odd. Well, n squared minus 1 is odd. Well, if I tell you that I have a number in my hand, let's call this number x. And if I tell you that 1 less than that, if I tell you the 1 less than that is odd, Well, what do you surmise about that number? What do you infer about that number? What do you gather about from that? For example, 5 minus 1 is 4, which is not odd, which tells me that this x must not be odd, must be even, because you see, even number minus 1 is odd. So that tells me that this x, whatever it is, must be even. That's what that tells us. If I have a number, and one less than that is odd, or one more than that is odd, then the number itself must be even. Because if you have an even number, if you add 1 to it, it will become odd, whatever that even number is. If I have a 10, if I add 1 to it, it becomes 11, which is odd. Perhaps I'm explaining too much. I don't need to explain too much, but I don't need to explain this much, but sometimes I feel safer. And similarly, if I have some number, if I subtract 1 from it, and it becomes odd, that number that I started out, it must be even. For example, 6 minus 1 becomes 5, it's odd. So whatever number, and here, since this number minus 1 is odd, that tells me that this number n squared, this tells us, that what this implies that n squared must be even. Because an even number, as I said before, an even number minus 1 will be odd. In other words, one number immediately preceding the even number, whatever that even number is, one integer preceding that would have to be odd, and one number following it would have to be odd. So this is 6. Then one before that, 5, is odd, and one after that, 7, is odd. That's all it is. So that tells us that n squared must be even. Well, if n squared is even, n squared is simply n times n. How can we find the product of two numbers to be even? Well, the only way the product of two numbers is even is when both of numbers are even. As you can see, but not the only way, but since this is even, and since it's the same number, sorry, I'm pointing to the addition here, the product of two numbers, you see, product of two odd numbers, odd times odd is odd. Odd times even, this rule, this case of odd times even is ruled out because it's the same number. We don't have two separate numbers, so it's the same number. And the product of the number, a number times itself, if that is even, the number would have to be even. Even times even is even, because that number times itself, had that been an odd number, then that number times itself, the product would have also have been odd. But we just told us that we just surmised that this is even. So that implies that n must be even. Must be even. I know I do this every time. You probably watched my clips before and you probably know it. But sometimes not sometimes, but most of the times I end up explaining way too much unnecessarily. I don't know why I do that. I guess I'm compulsive. But anyway, n is even. The question is n even? The point here is not that we were able to actually figure out that n is in fact even. The point here is that this information is enough to establish whether or not n is even. This information is enough to answer the question either in the affirmative or negative. In this case, it happens to be positive. Answer happens to be positive. Yes, n is even. So the first information, the first statement by itself is enough to answer the question that is being asked: is n even? I forgot to do something. This is the data sufficiency problems. The very first thing we should have done is to write down. Let's do it here. A, D, B, C, E. Always get in the habit of doing that. I forgot that. We just figured out that statement number 1 by itself is sufficient to answer the question. That tells me that the answer cannot be B, C, or E. Answer would have to be either A or D. If it turns out the second statement by itself is also sufficient to answer the question, then the answer would be D. Let's look at second statement. We're done with the first one, so I'm going to erase it. Let's look at second statement. Second statement says 3 times n plus 4 is even. Well, if 3 times 4 is even, we already know that this is even. How can the sum of two numbers be even when we know that this is already even here? the 4. I meant to put a 4 in that box. This is our 4. How can we have even the sum of the two numbers be even? Well, here it is. Either they both have to be odd. That's one way of getting a sum of two numbers to be even when they are both odd, or they are both even. But they cannot both be odd because we are told that the second number here is 4. That tells me that this number, first number, 3n, this implies that 3 times n must be even, because that's the only way we're going to get the sum of the two numbers to be even. Even plus even is even. Odd plus odd is even, but this is not an odd number, this is an even number. And since the sum of this number and this number is even, this is one number, even though it says 3 times n, 3 times n is actually one number. That number would have to be even. And now here we have product of two numbers, 3 and n. For 3 we know is odd. How can we have the product of two numbers to be even? Well, let's take a look at it. Product of two numbers is going to be even when the numbers that we're dealing with are both even. Even times even is even. Odd times odd is odd. This is odd. This 3 is odd. So that rules out this first case. We're not dealing with two even numbers because 3 is odd. And if the other number was also odd, if n was also odd, or rather I should speak hypothetically, if n were also odd, then odd times odd would have been odd. But we are told that this thing, 3 times n, must be even. We just established this thing because this is even, and the sum of two numbers is even. Therefore, this whole thing has to be even. So the 3 times n has to be even, which is a product of two numbers. 3 and n is even. First number we know is odd. The first number we know is odd. Second number is not odd. The second number, this number times this number is even. So we're dealing with this case right here. The first number here being the 3, and the second number here is our even number, that's our n. And 3 times n is even. So that tells me, this implies that n must be even. N must be even. Hence, the second statement by itself is also sufficient to answer the question that's being asked. It also does the job, and therefore the answer is D. Sometimes I cannot tell how far I should go in the explanation. As I explained to you as I explained to you already a few times in the past, and if you watch my other clips, that and this dilemma is not just for myself, it's for any teacher, any instructor with a little bit of experience can very easily gauge the ability of the student, the client, whatever you want to call them. It doesn't matter if the client is sitting face to face or is over the internet or over the phone. We can very easily gauge the ability of the client very easily in a short period of time as to where that person stands and how much help they need. But since I do not know who is watching these clips, and I don't know what your ability is, and there are people from different background watching it, so I sometimes tend to go into a little bit more in depth. And for some of you, it's probably unnecessary. I realize that. I understand that. But that's just the nature of the beast, I guess. You just have to put up with it for the sake of other students who probably do need more help. So anyway, that's what that was. I hope you found it helpful. If you wish to get hold of me for personal private tutoring, I do face-to-face tutoring obviously. I also tutor over the Skype, over the internet, online, and I also tutor over the telephone. If there is anything at all that I can help you with your preparation for GMAT, go to my website at www.prep.gmat.com, prep4gmat.com, or you can go to www.keshwaniprep.com and send me an email. Alright? And we'll go from there. Thanks.